This video is going to discuss rational exponents. So rational exponents are just another way of writing a radical. An expression with rational exponents can be rewritten as radicals using the following rules. So this is kind of like fraction form versus decimal form. So think about it like that. You know, we know that 1/2 equals 0.5. We know that 3/4 equals 0.75. This is just a different form of radical form, or a different form of writing radicals. So here's exponential form. And a rational exponent means that your exponent is a fraction. So I kind of think that rational sounds like fraction, okay? And yes, I said it funny on purpose. Rational fraction, rational fraction, rational fraction, okay? Think about fractions are ratios. That's where that relationship comes in. So rational exponents are fractional exponents. And a to the 1 over n power means that is the nth root of a. So if we were to rewrite this in radical form, it would be n root of a. Now, if we have something besides 1 in the numerator, it means the nth root of a raised to the mth power. That was really fun to say. So we have the nth root of a to the m. Okay, and we're going to do a couple of examples, and it's going to make more sense when we actually put numbers there. Okay, so remember that x to the m over n is equal to the nth root of x to the m power. So I kind of think of this as like the top number stays at the top. You know, the top number is the exponent, the top. I don't know. In my brain, that makes sense. You find your own way to remember and to make sense of this rule. And maybe for you, it's just memorization. For me, I remember it like the bottom one has to move and the top one gets to stay at the top. You do you. Okay, so using this, let's rewrite our expressions. So in this case, m is 1 and n is 4. So this is going to be the fourth root of x to the first power, which we know is just equal to the fourth root of x. Okay, so not too difficult. It does say to simplify if needed, but in this case we didn't need to. So let's try it on a number now. So again, the top is m, the bottom is n, and if we look at this, it's going to be the cube root. Sorry, that is pitiful. The cube root of 24 to the first power, which we know is just 24. But this one can be reduced because there is a perfect cube that goes into 24. So we're going to split this up into the cube root of 8 times the cube root of 3. And then the cube root of 8 is 2. So we will get 2 cube root of 3 as our answer. Oops. Beautiful. Okay, number 5, k to the 7/2. So remember, this is m and this is n. This is the square root, and we don't have to write the 2 whenever it's a 2. Yeah, we don't have to write the index when it's a 2, sorry. Square root of k to the 7th. Now remember, whenever we do this, to simplify this value, we remember that this is a 2. 2 does not go into 7 evenly, so we know we're going to have some k's outside a radical and some k's inside a radical. We just don't know what these exponents are going to be yet. So the way we figure out the exponents is 2 goes into 7 3 times with 1 left over. Okay? So k cubed square root of k is the simplified version of this value. I also want to show you one other way. So take a second, copy this down if you need to. I'm going to erase it all. I want to show you a different way to simplify k to the 7/2. All right? So this is you can rewrite k to the 7/2 and write 7/2 as a mixed number. So do you remember that, when you did mixed numbers early on when you learned fractions, we would know that 7/2 can also be written as 3 1/2. So you do not have to do this way, but sometimes this makes more sense, and I want you to have this in your toolbox. I want you to know that it's a way to do this. But if it confuses you more, then just ignore it, okay? Don't worry about having to wrap your head around this part. So, k to the 3/2, or 3 1/2. This is going to be rewritten in radical form as k cubed, and then we just learned that something to the 1/2 power means the square root of that. So this is going to be k cubed times the square root of k to the 1st. So this number tells you how many come out, and this number tells you that the exponential form of this radical. I'm actually going to show you this on a couple more problems as well later on. So if you don't have your head wrapped around it just yet, that's okay. Also, it's optional. So you can pause the video here and finish numbers 1 through 9 and then come back when you're done. And now we're going to move into converting radical exponents or radical form to exponential form. So in the last problems, we were going the other direction. We went from exponential to radical, but this time we want to go radical to exponential. And this is just to get practice, okay? So this does not ask you to simplify, it simply wants you to write it in exponential form. So no hard thinking, only moving things around, okay? So this value becomes your big number. And then actually, let's look at the form again. So x to the m over n equals the nth root of x to the m, okay? So this guy is your base, and 16 is to the 1st power, so the numerator is 1, and it is the 3rd root or cube root, so the denominator is 3. And that's it. We just have to rewrite it. Now this one where we have multiple things under the radical, we have to write 8w in parentheses. So we're going to have 8w, and then it's to the power of 1, so that is a 1 as a numerator, and then a 4 on the denominator. All right, that's it for that one. So we got this answer, we got this answer, and now we got this guy. So k to the 5 over 4 power. That's it. All done. So you can go ahead and pause the video again and finish numbers 10 through 18. Hopefully they won't take you very long. And then we will move on to simplifying rational exponents. And there's a little bit of a process to this, but really it's a lot of what you've already been doing. It's not super different. All right, the first thing we're going to do is rewrite all radicals in exponential form. Well, in this case, everything's in exponential form, so we don't have to worry about that. Then we use exponent rules to simplify the expression. And all that exponent rules are is that we know when you multiply like bases with exponents, you add the exponents together. So this is going to be x to the 1/3 plus 4/3 is 5/3. And then, so we simplified. Now we want to write our answer as a radical in simplest form and rationalize if needed. So we talked about rationalizing in division. So go back and review that if you need to. You're not allowed to have a radical in the denominator, so keep that in mind. Okay. We have x to the 5/3. So there's two ways of doing this. Option 1. You can do the cube root of x to the 5th, and then we know we can reduce that to be x cube root of x squared. Or option 2, you can change this to say x to the 1 2/3 power. And that means we're going to get x to the first power times the cube root of x squared. So this 1 goes here, the 3 goes here, and the 2 goes here. All right, either way is fine. You don't have to memorize option 2, but sometimes it's easier to think of it that way. All right, let's try another one. Write everything in exponential form. That's done for us. Use exponent rules to simplify. So when we divide with exponents, we subtract them. So we need to do 5/2 minus 7/4. So we need to convert the halves to fourths. So we're going to get 10/4 minus 7/4, which equals 3/4. So that's what's going to go here. So m to the 3/4 can be written as the 4th root of m cubed. And that's your answer for this one. That one was pretty simple. Okay, let's try number 23. It's already in exponential form. We are going to do an example where it's not in just a second. But this one is already in exponential form. Actually, I don't have any examples picked out. But that's okay. You practice converting. You know how to do that. Okay, so then we're going to use exponent rules to simplify the expression. So when you raise a power to a power, you multiply them. So this is going to be 32 to the 1/2 times 1/2, which equals 1/4. So 32 to the 1/4 power. That means the 4th root of 32. We know that there is a 4th root that goes evenly into 32. That 4th root is 16. So we're going to do the 4th root of 16 times the 4th root of 2. The 4th root of 16 equals 2. And so this is our final answer. All right, the last example I'm going to do with you, I picked out because I wanted you to pay attention to this negative. They're kind of hard to see. I would go through the whole worksheet and pick out all the ones that have a negative and put a star beside them, because that is going to throw you off. Make sure that you pay attention to those. All right, so when we have a negative exponent, that means that we are just going to take the value that we have and put it under 1. So we're going to put it as the denominator of a fraction, and that turns our exponent positive. So 100 to the negative 1/2 is equal to 1 over 100 to the positive 1/2. So now we can have 1 over the square root of 100, and we know that the square root of 100 equals 10. So the answer to this problem is just 1/10. All right. You can pause the video and finish up your worksheet here, or you can go back to the answer key that's linked in the binder. Hope you guys have a great day.